This is my solution for the problem that we did on Wednesday of week 5, and we were doing banked curves. And we said that you can drive on a curve. You can drive on a curve that's banked at some angle theta as you're going around in a circle. So your acceleration is this way, centripetal acceleration, v squared over r, inward to the center of the circle, even if there's no friction. How's that possible? The free body diagram really illustrates how that's possible. There's a normal force that goes this way, and there's mg going this way. And that's pretty much it, actually. Yeah, that is it. There isn't anything else. And so I'm going to choose axes that go like this in the x and y direction. So that means I have to take my force and resolve it into two components. And this angle here is theta. So we have the f sine theta component in the x direction and the f cosine theta component in the y direction. So then I write down that the sum of the forces in the x direction and the sum of the forces in the y direction. So the sum of the forces in the x direction is just f normal sine theta. In the y direction, it's f normal cosine theta minus mg. Now, if we want the person just to go around in a circle, we don't want them to go up and down the ramp. So we don't want any acceleration along the ramp, which means there's no acceleration in the y direction. So this has to be 0. The only acceleration that there's going to be is in the x direction, and furthermore, it has to be v squared over r. So we can start to see now already how this is even possible. So the force that's in the horizontal direction is the force that provides the centripetal acceleration. But the rest of the normal force in the vertical direction has to balance out gravity. Okay, so we'll just keep going with this and see what we get. And the question was, find the safe speed as a function of the radius of the curve and the angle. So the one thing I don't know is the normal force, so I'll take this equation and solve for the normal force. Okay, and then I'm going to plug that back in to the top equation, and I get that the normal force, mg over cosine theta, times sine theta, is m v squared over r. I can divide both sides by m, and I have g. Let's see, sine over cosine is tangent theta. So if I solve for velocity, I get that the velocity is the square root of g r tangent theta. And that's the answer.